Step one, always circle theta. So we circle it. Step two is to draw and label your opposite. Next was to find the hypotenuse. Hypotenuse never changes, always across from the right angle. Process of elimination gives you then your adjacent. You've gone through the first 4 steps. It took about 3 seconds. Okay? From there, you ask yourself which trig function you have to do. So that means you have to look at, I need to find x. X is my adjacent. The other side length that I know is my hypotenuse. So which trig function has adjacent and hypotenuse? Adjacent hypotenuse. Cosine. Okay. Sure. So then I have cosine of 24 is my adjacent over the hypotenuse. Now you're back to your trig. Which trig setup is it? Is it numerator unknown or denominator unknown? It's numerator, which means all I have to do is move 14. So your answer should have been 14 cosine 24 is x, and you left it. Okay? I know that when I walk through these things with you guys, it takes a little bit longer because I'm kind of walking through them slower. But I'm sure you guys, when you're doing it, you're probably flying through it. Okay? You're probably flying right through it. So, were there any, before I just pick a couple extras here, were there any on there that you thought you maybe got backwards or something? You wanted to just double check real quick? Yes, sir. No problem. So, go through the steps. Circle theta. We circle theta. It's 49. We draw to our opposite. Label it. Find the hypotenuse. Label it. Process of elimination tells you have an adjacent. Which trig function do you have? Well, you're trying to find a hypotenuse, because that's where the x value is. So you know it's either going to be sine or cosine, because it's the only 2 functions that have the hypotenuse in them. So it depends upon what's the other side length that you know. The other side length that I know? It's okay. the other part that I know is the adjacent. So again, I'm going to use cosine. So I write it out. The cosine of 49 is 16 over x. Now this is the one that you have the trig with the unknown in the denominator. So we do our good old-fashioned exchange-o, change-o as we write it out. And that's what you should have left it as. What's Justin? Justin? Justin, they're moving your car. I'm just. Nikki's looking for you. Well, that was funny though. You kind of what? So that's all you had to worry about. As you go through these things, guys, that's all I wanted you to be able to do from yesterday. It's just to look at what you're doing, go through the steps, and identify the parts. That's the main trick for trig. Understanding which setup you're using, which trig function you're going to wind up with. How do you get the algebra step to work? Because when you get to this part, it's just a one-step algebra problem, no matter what. But if you don't have the rest of the stuff set up the right way, no matter what you do, it's going to be wrong. Okay? Does that make a little bit more sense? All right. Is there any others you wanted to look at real quick? Yes, ma'am.
Wait, no, I'm just not to look at. But are you going to be usually more slide? Because I didn't get a lot of.
It's okay. It's just I just printed one and I didn't go through to make sure there was an even amount. It's just a random thing when you press the buttons when I made the worksheet. And you're right. It just really depends on what Mr. Kuda spits out when I hit enter. Okay. Yes, sir. Sure. Not a problem. Not a problem. I'm well, man. You? I'm tired. I'm sorry. All right. Okay. Go through our steps. First step, circle your theta. Theta in this case is 65 degrees, so we circle it. Then we draw to its opposite. Bring over to your hypotenuse. And then the last one is your adjacent. Okay? Always do the adjacent one last, because that's, by process of elimination, the last one that's there, so it's kind of tough to screw that one up. And then from there, it's just a matter of now, what are you trying to solve for? In this case, again, we're trying to find a hypotenuse, so it's either going to be a cosine or it's going to be a sine, depending upon what other side length you know. According to your diagram, when you labeled it, you had an opposite. So you're going to use sine. That's why we label and go. So we have a sine of 65 is your 16 over x. Okay? From here, we just go ahead, since it's in the denominator, no matter what the trig function is, whenever that unknown is down here, we just change-o, and you're going to get x is 16 divided by the sine of 65. Okay? I have a feeling you called this 16 an adjacent. And what's weird with those sometimes, because when you've got this skinny triangle like that, this skinny elongated triangle, sometimes it's tougher to see which one's the actual opposite. So if that happens, sometimes what I would tell students is just to kind of trace the actual angle, because that angle will open up to the opposite. Does that make sense? So, because where was your unknown? It's in the denominator, right? Remember when we had our trig function? If the unknown is down here, you just multiply, you switch those two. Okay, that was the trick. Whenever it's in the bottom, you switch them. There's a long-winded way of doing that without looking at trig functions and whatnot. Let's say this was 3 equals 7 over x. In order to move the x value, it's divide by, you'd multiply both sides by x. That x would go away, you'd get 3x equals 7. Then you would divide by 3, right? And you get x over 7/3. Notice all I did was just switch them. It's the same thing, just remember the sine of 65, it's just some crappy decimal. You treat it the same way. That's why I keep putting this stuff up together, because it's always going to default to one of these two. When you're trying to find a side length, it's either going to be one of these two. And no matter what, it's either this method or this one. So if you remember those two, you're going to be all right. Okay? So, let's do these real quick. Let's see. So 1, did you guys use a tangent? I just want to make sure you guys did the right trig functions for this. Tangent. 2, you used cosine. 3 we just did was sine. 4 we did was a cosine. 5 looks like it was a sine also. Yeah. 6 we did, that was another cosine. 7, did you guys use cosine again?
Yes, sir.
What do you got memorized?
Maybe.
Yeah, and then lastly, did you use tangent for 8? Okay. At least we got the right trig functions, okay? At least we got the right trig functions. So, second step of this stuff then, since we're doing all this stuff okay, is to go to the next step, and what do you think that is? Press the button. Okay? So, let me give you guys some examples. That way you don't have to continually draw and go. Do you want your quiz now? That's fine. Not a problem. We will be using some buttons here, guys. But still getting the same setup, same thing as we go through. Okay. Now we have school this week. We have school next week. There's a half day on Thursday. That's it. Correct. President's Day. Yeah. Would you mind grabbing the big calculators out of the cabinet, please?
Oh, never mind.
Wishful thinking, isn't it?
I know. Friday.
And it was the same thing last week. I thought last Thursday was Friday because I forgot we had Institute Day on the Friday. And plus, I get quizzes all day. Usually, I do quizzes on Fridays. And I thought I was. Then I found out it wasn't, and I was very sad.
Yeah,
So let's take a look at this. Make sure I have the right date. 4/22. Cool. All right. So here's what I want to do. I want to set this stuff up and work through it the exact same way that we have been. But in the end, I want to explain to you guys how do you utilize the button stuff correctly, and how do we always make sure we're rounding the right way. I'm always going to say round to the nearest hundredth. The nearest hundredth is how many decimals? 2. Okay. So we're basically adding one last step here to this little work through, and that's going to be press buttons. Yeah. Okay. So let's start with number 1. And the reason why I gave you guys this one, I heard more nuts.
Yeah, you did. Maybe next time you should remember. The door.
So, as we go back into this one, oops. First step is to do what? Circle theta. Good. It's theta. It's spelled Theta. Theta. I got half a fake front tooth, so it's hard for me to say that a lot of times. So. And that's another way of looking at it. Yeah, you're right. If you look at it in textbooks, it's usually written like that. Sometimes they have it a little bit more of a cursive style, like that. Either one of them, it means the same. It just depends on how they write it, what their production is. You know, if that makes any sense. But yeah, the Greek alphabet there's different ways of representing a bunch of them. You'll see it sometimes even. Is it this one with or is that something else? I don't remember. I don't remember my calculus class, to be honest with you, but that's okay. First step.
No, I said you're doing great. I did not say that.
You know, please. Yeah, you're what she said. That's true. That's true. You know what she's gonna do? She wants Circle. Label is the next step. Label our opposite. Find the hypotenuse. Process elimination. And then we ask what trig function. What trig function we have to use here, ladies and gentlemen? Sine, good. So we know that it's going to be the sine of 50 is x over 16. Is our unknown in the top or unknown in the bottom? In the top, which means it always follows this rule. So all I have to do is multiply by the bottom. So I rewrite like you did yesterday. 16 sine 50 is x. From here, we are exactly where we were at from yesterday. Now we need to make sure we press buttons correctly. So first things first, I think I mentioned this yesterday. In your calculator, or on your calculator, in the upper right-hand corner, it should say DEG. Okay? It should say that. If not, I'll show you how to change your modes, but for the most part, you should be okay. If you ever wind up using your phone, if you don't have one of these calculators lying around, or you have a graphing calculator, or you want to borrow a friend's graphing calculator or whatever, you have to make sure it is in degree mode, otherwise you're going to get incorrect solutions. Okay. An easy way to check that, if you wind up with a calculator for the graphing one, if you hit the button it says mode, if it loads, but anyway, regardless, doesn't all load. So when I go to enter this in the calculator, the reason why I like to write these things out like this is because I can type them in the calculator exactly the way I wrote it. That's the whole reason why we do it this way, guys. That's why we write it up with the fraction bar and we put it one over the other. Because in the calculator, I can replicate this exact thing, 16 sine 50, and hit enter. And that's my answer. Okay? I don't have to hit a times button or anything, because once I put that 16 out in front of the sine value, it knows to multiply. So when I look at that, I have to round now. And this is where a lot of students seem to have forgotten. How do you round this? If I'm rounding to the nearest hundredth, I need to go to this here, and I look at the third digit. Is the third digit bigger or equal to 5? Or sorry, is the third digit greater than or equal to 5? Greater. So what do I do with the second digit? Round it up to 6. So my answer here would be x equals 12.26. Okay?
So I always heard from rounding
If it's 4 and down, 4 and under, you just keep it the same.
That's what I meant.
Okay.
That's what I meant by rounding down. Yeah.
Okay.
So then you said you asked if it was greater or equal to. So what would you make?
I would still go up.
Okay.
Yep. Yep. If this was 255, it would still be 26. So I know I added a lot of work to you. Was that too much?
No.
I wouldn't care what you say anyway. I would just take it with a grain of salt. Oh, the marketing skills of you guys, I tell you. All right. Look at the second one. Again, first step is to do what? Circle it, and label. So I circle, draw, label, hypotenuse, adjacent. According to the picture, what are you trying to solve for? Trying to find an opposite. Since we're trying to find an opposite, I know it's either going to be a sine or a tangent, depending upon what's the other side length. This one's going to be tangent. Good. So there's your tangent one. So tangent of 22 is x over 13. Once again, opposite over adjacent. So the x is the opposite, the 13 is the adjacent. I just leave it like that. Now, it follows the unknown in the numerator, so I just have to move the denominator over. And I get 13 tangent 22. What's that? Now, do you guys see what I mean by all the different buttons that are there that we're pressing all the time? It's so easy as you're typing this in to accidentally hit cosine by mistake, okay? That's why if you write down what you're doing before you do it, I know how to check it, okay? So in this one here, when we round it, so I have 5.252, so I'm looking at that third digit, and since that's less than 5, my answer is just going to be 5.25. And I leave it. Okay, and I'll leave it. Yes, sir?
Why not start at the 9 and constantly round up until you get
Doesn't matter. You can do 5.
Thank you, sir. Okay. Let's see. Let's look at 3. What's your first step? Circle. Then 17's our opposite. X is the hypotenuse. Adjacent. Even though we're not using all 3 side lengths in these problems, guys, there's a reason why I like to label them all out, because eventually we're going to solve for everything. But for right now, we're just doing one piece at a time. Okay? What trig function works with opposites and hypotenuse? Sine, very good. So we have the sine of 62 is 17 over x. Now where's your unknown? Top or bottom? The bottom, which means what do I have to do? Exchange. Exchange, it's not just exchange, you gotta say it the right way. It's exchange-o. Change-o. It's much cooler. Ouch. Now, I wanted to make sure I showed you guys what to do when you have one like this. When you have this, there's a bar, a fraction bar. Use it. You're going to replicate what this looks like. Huh, who would have thunk? That's why we write it like that. Fraction bar, 17 over sine 62, and hit enter. What's that? Okay. And I get 19.2536, which means it's going to be 19.25. Now, I want to show you guys what can happen when you don't, or if you hit the wrong button, okay? So, I'm going to go back to the same thing. I'm going to clear all this out. And we knew that it was going to be 17 sine of 62, 17 over sine of 62, correct? So, let's say you're doing this, 17 fraction bar, and then you just did that really, and you accidentally hit cosine by mistake really fast. Would you have any idea to know that that decimal is wrong? There's nothing in your mind that knows that that value is not going to be correct. Okay? What's happening here, and that's the whole idea by writing this part out first, because if it does come to something like this, I can easily backtrack and figure out what you pressed. Okay? It is so unbelievably important that you always, and in instructions and quizzes and tests, I will always have on there, write down what you're going to put in your calculator before you do it. That way I can double check. Yes, ma'am. There will be a time, and I'm glad you asked this question, there will be times where the numbers themselves will be a little bit weird. For example, let's say we did, and I know this one's not on your sheet here, but let's say we have a 30-degree angle, and we're trying to find x, and we know that this is 6, okay? If we did this, if I follow the same pattern, first thing I would do is circle my 30, correct? Draw to the opposite, label the hypotenuse, get an adjacent. Now in this scenario, what trig function would you use? Very good, you're going to use cosine. So you would write cosine of our angle, which is 30, is our adjacent 6 over x. Again, we got a little exchange going on. So we do that. X equals 6 over the cosine of 30. Now, put that in your calculator. When you put that in your calculator, you might see something a little weird. 6 fraction bar. It is. Yep. Is that okay?
Yeah.
Absolutely. Because isn't a 30, when you see a 30 in a right angle, isn't that a special right triangle? So the trig stuff works with special right triangles, and you're going to get weird roots sometimes, okay? So guys, if you've got a 30, 60, 90, or a 45, 45, 90 triangle, the trig stuff will still work. Also, the weird thing that'll happen is sometimes you get a 75 degree. Oh yeah. Sorry, I think I had a question there. All right, so if you see a 75-degree angle and you'll wind up with some really weird square root stuff, it's okay. You didn't do anything wrong. The multi-view calculator is just simplifying its roots as it goes through, okay? That's all that means, all right? That's all that means. Why don't you guys take a minute and try out, let's see. Let's just do 7 through 10 real quick on our own. Write out what you're doing, round to 2 decimal places. We'll come back together and check them here in a minute, all right? Hey, there's still time to change that in a roundabout kind of way. See what O in the circles?
Oh.
Yes, just don't care. That's all right. There's our op. Did you use tangent for number 7? That's a good sign. So you had tangent of 58 was 13. Yes, ma'am. Who is? Don't give me your lip, lady. Switch them around. So 13 tangent 58. See if I did this correctly. 13 over the tangent of 58. I'm getting 8.12. Did she hit you?
No, I did not.
I'm just gonna go here to 9. On number 9, hopefully you use sine. You get 14 over the sine of 64. 14 over the sine of 64. 15.58.
Yeah.
15.58 for number 9. Okay. And here at 8, I guess it's another sine. There's your opposite, hypotenuse, adjacent. So sine 70, 10 over x. So 10 over sine 70 and enter 10.64. Yes, sir. For which one? Oh, for the last one? That's fine. Because, see what I'm saying? Remember how we said we were talking about every time you get a special, you can still use trig and get a root, that's okay. There's nothing wrong with that. And then on 10, you guys probably noticed by now that since this is a special angle, whenever you have a 30, 60, 90, or sorry, a 30, a 60, or a 45, when you do trig stuff, it's very well possible you're going to wind up with one of the square roots, and that's okay. All right, there's nothing wrong with it. All right. So when you did this one, you had this one was a tangent, so it was tangent of 60 was 12 over x. So you had x was 12 over the tangent of 60, and you got, I think this was 4 root 3, wasn't it? Yeah. There you go. Okay. That's what we're working on, guys. Not terrible? Yes, sir. Yes, sir. If the calculator ever gives you, this is a great question. If the calculator ever gives you a root for an answer when you're doing trig, just leave it. Okay. Like I said, you're gonna see, and I don't know. Let me see if this one I did it. No. On the, if you ever have a 75-degree angle, you could get a weird answer also, but this one doesn't have that. So let's see. On the back side here, why don't you guys finish the back? We'll call it a day on this. We'll talk about how to set up angle stuff tomorrow. Yes, sir. What's that? Look to the third digit. If the third digit is a 5 or greater, it rounds up. Second digit, if it's lower than 5, the second digit is the same. Okay? All right? Finish that back side, and remember, always write out your steps and show what you're about to press in the calculator prior to pressing the buttons. Okay?
I just did 16 sine.
And did you see it?
You forward 6 before we do.
There's a reason why it does that. The reason why it does that is you have a 30, a 45, and a 60. Isn't 75 degrees 15 plus 60? So what happens is in calculus, you deal with what are called half angle or double angle formulas. So there's a half angle formula for trig functions when they're at 75 degrees, if you will. 4 root 6 plus 4 root 2, it'll just spit that back out and let you hit the double arrow button. You don't have to worry about it, Sam. This isn't even an abs, or I'm sorry, I don't even teach this part in my honors algebra 2 class. They teach this stuff in pre-calc when they get to the trig functions for those two formulas. It's not a big deal for you guys. It just so happens that if it spits out one of those double roots, you can just write it down or hit the double arrow. Maybe that's when it's cool. All right. There is something funky going on out there. Yes, please. I honestly don't think this should take you more than 10 minutes, 15 tops, okay? Even if you guys don't have the calculator, if you guys don't even have the calculator, you can still, guys, you can still write out everything and then just press buttons at the end, okay? Oh, sure, not even looking at your pencils? Whatever. Jerk. Uh-huh. Where are you going? Ooh, fancy pants. Nice. That's awesome. That's very cool. When's your birthday then? Oh, well, happy birthday a few weeks ago.
A few weeks ago.